Hi, so before we step into the code, let's first understand the shape of today's problem. So this problem is about permutation. So in other words, it asks us to take the same group of numbers and arrange them in every possible orders. So the numbers themselves does not change, but their position creates different answers. So today we mean theorem is choices. At each step, we choose one unused numbers, place it into current path, and continue forward. When the path reaches its end, and we return, undo the choices, and open the door to another possibility. So for this simple movement, like choices, explore, and return, we enter the world of DFS and backtracking. So the question asks us to return all possible permutations in distinct integers. So in simple words, we are not selecting sum of numbers. We are arranging all of them. So this is very important because every answer must contain each number exactly 1. Nothing is lost and nothing is replaced. So the task is not about whether a number belongs to the answer, but where it should stand. So the problem becomes a small philosophy exercise in orders. Given the same elements, how many different worlds can we create simply by changing their positions? So that naturally leads us to the next example. So let's look at the names equals to 1 to 3. If we choose 1 first, then we remaining the string is smaller, only 2 and 3 are left. So from there we can form the 2 answers. But the search does not stop there. We return to the beginning, remove 1, the answer, and ask another question. So what if 2 comes first? And what if 3 comes first? So this is the beauty of permutation. The numbers do not change, but their order changes the identity of the answers. So for 3 numbers, we get 3 factorial, which is 6 possibilities. Now we need the method that can work through all these probabilities without confusions. So the main method is DFS with backtracking. So at each level we make a choice and we choose one unused numbers, place it into the current path, mark it as used, and then go deeper. But deeps alone is not enough. A wide search must also know how to return. So after explore one branch, we undo the choice. We pop the number from the path and mark it as unused again. So, but how do we know when one possibility is complete? So the important line is stopping condition. When the length of the path equals the length of names, at that moment the path has become a complete word. Every number has found a position, every choice has been made, so we save it as one answer. But we must save path copy, not path itself. This detail is small but deeply important. The path is still alive, but it will continue to change as backtracking continues. And if we save the original list, our previous answer may be changed by future choices. So in code, memory require protection. We preserve the answer by copying it. Now let's see how the idea becomes to the code. So in this code, the restore all completed permutation. The use array tells us which index has already entered the current path. The dfx function represents the art of explorations. So inside the loop, if a number is already used, we skip it. Otherwise, we choose it, mark it, go deeper, and then redo the choices. So this four-step rhythm is the whole algorithm. And if you want to remember this map more clearly, we can compare it with an earlier problem. So the difference is the problem 14. So that question we use the combination, which means that order does not matter. But this question is a permutation. So it is arrangement. So that means order is matter. So that's the difference between these two questions. And if you are interested, you can do that later. So that's the whole question I want to say. Thank you very much.